Contents. Definitions. Why is pre-stressing useful in concrete members? Differences between reinforced concrete and pre-stressed concrete. Disadvantages of pre-stressed concrete. Advantages of pre-stressed concrete. Definitions. Pre-stressing is the creation of internal stresses in a structure or system to improve its performance. A pre-stressed concrete member is one in which there have been introduced internal stresses of such magnitude and also distribution that the stresses resulting from the external loading are contracted to a desired degree. Why is pre-stressing useful in concrete members? In reinforced concrete, concrete is strong in compression and weak in tension. The tensile stress is equal to 8% to 14% from the compressive strength F'(C). Flexural cracks cure at relatively low loads. In a pre-stressed concrete member, a compressive pre-stressing force can be applied concentrically or eccentrically in the longitudinal direction of the member. This prevents cracks at critical midspan and supports a service load. Section can behave elastically. Bending, shear, and torsional capacities are increased at these sections. In this figure, we can see a concrete beam will begin to bend when heavily loaded. The base of the beam starts to crack where the concrete is pulled apart. Here we can see placing a steel rod inside the beam. This leads to hold the concrete together and stop the beam from cracking. Here we can see the stretching the rod and then releasing it to squeeze the concrete and makes the beams very strong. In this figure also we see in 1 and 2 the beam without tendon and the load deflections goes down, while the beam in 3 stretching tendon and 4 the tendon will be released. Hence the concrete is subjected to pre-stressing force, compressive force. This leads to camber the beam, and in 6 we can see the beam when we loaded it with dead load and live load, the total deflection will be flat. Concentrically or eccentrically in the longitudinal direction of the beam. In this figure, the tendon is put in the centroid axis of the beam. This means concentrically. In this figure we can see the tendon is put below the centroidal axis. This means eccentrically. Differences between pre-stressed concrete member and reinforced concrete member. In tensile strength. Reinforced concrete, tensile strength of concrete is assumed to be negligible. In a pre-stressed concrete member, permanent stresses are created prior to full dead load and live load. This led to reduced net tensile stresses. Cracking and deflection. In reinforced concrete cracks only half to 1/3 of concrete cross-section contribute to effectiveness. In a pre-stressed concrete member, little, if any, cracking inter-cross-section contributes to effectiveness. Cracking and deflection in reinforced concrete member are typically irrecoverable after reaching this limited state. A higher level of recovery of cracking and deflection due to pre-stressing force. In reinforced concrete, surface deflections are typically large, while in pre-stressing reinforced concrete, surface deflection are small, camber, reduced deflection, and full section is stiffer. Both reinforced concrete and pre-stressed concrete deflect appreciably at ultimate loads. Stiffness. Reinforced concrete stiffness is difficult to control economically. In pre-stressed concrete, stiffness can be flexible or rigid by controlling amount of pre-stress for a given strength. In shear, reinforced concrete, no direct assistance from longitudinal steel. In prestressed concrete member, some assistance from longitudinal steel. Servability. Reinforced concrete heavy. Prestressed concrete member lighter weight, can accommodate longer spans, more adaptable to precasting. Economy. Reinforced concrete more material. Prestressed concrete less material, but higher cost material used. Disadvantages of prestressed concrete: higher material cost. Prestressing is an added cost. Formwork is more complex than for reinforced concrete. Plunged section, thin webs. Not as ductile as reinforced concrete member. Advantages of prestressed concrete: high strength steel and concrete. Prestressed concrete 20 to 35% of reinforcement in reinforced concrete. Lighter section, longer spans. Prestressed concrete depth equal to 65 to 80% of reinforced concrete depth. Lighter foundation possible. Intersection is effective, more efficient. Crack less, better corrosion resistance, better durability. Deflection control, critical for spans greater than 70 to 90 foot. Excessive dead load. Better shear resistance. Inherent safety. Highest prestress force is applied when concrete is weakest during construction, but cost can be brought closer to reinforced concrete members for large quantities. Indirect long-term saving is large. Less maintains, longer life possible, quality materials. Best solution probably a combination of prestressed concrete and reinforced concrete. It's called partial prestressing. Thank you.